Space, the final frontier. It's a vast expanse that has captivated human imagination for centuries. From the twinkling stars that dot the night sky to the mysterious planets that orbit distant suns, space has always been a source of wonder and inspiration. It inspires wonder and a desire to explore the cosmos. The thrill of launching rockets, the excitement of spacewalks, and the dream of one day setting foot on another planet drive us to push the boundaries of what is possible. But as we venture further into the void, we leave traces of our presence behind. Each mission, each satellite, and each piece of equipment we send into space contributes to a growing problem. It's time to face a growing concern: space debris. These remnants of our past explorations are accumulating in Earth's orbit, creating a hazardous environment for future missions. Our planet is surrounded by a growing ring of debris. This cloud of space junk includes everything from tiny paint flecks to defunct satellites and spent rocket stages. This debris poses a serious threat to our future in space. Collisions with even the smallest fragments can cause catastrophic damage to operational spacecraft, endangering missions and lives. Imagine a busy highway with vehicles speeding at thousands of miles per hour. Now picture that highway littered with everything from tiny screws to defunct cars. That's the situation in Earth's orbit. This debris field, remnants of past and present space missions, is on a collision course with our future ambitions among the stars. Each piece of debris is a potential hazard, moving at incredible speeds and capable of causing immense damage. This debris field, remnants of past and present space missions, is on a collision course with our future ambitions among the stars. If left unchecked, it could severely limit our ability to explore and utilize space. We must address this issue before it's too late. Scientists and engineers are already working on innovative solutions to mitigate the problem, from designing debris-catching satellites to developing methods for deorbiting defunct spacecraft. Our future in space depends on it. By tackling the space debris problem head-on, we can ensure that the final frontier remains a place of wonder and exploration for generations to come. What exactly is space debris? It's any human-made object orbiting Earth that no longer serves a purpose. This includes non-functional satellites, spent rocket stages, and fragments from collisions. Even tiny paint flecks traveling at high speeds can cause significant damage. This debris poses a serious threat to active satellites and spacecraft. Imagine a tiny piece of metal, no bigger than a coin, smashing into a satellite at 17,500 miles per hour. The impact could be catastrophic, potentially destroying the satellite and creating even more debris. This cascade effect, known as the Kessler syndrome, could make space exploration increasingly difficult and dangerous. The threat of space debris is not theoretical, it's a present danger. In 2013, a Russian satellite, Cosmos 2251, collided with a U.S. communications satellite, Iridium-33. The impact destroyed both satellites and created thousands of pieces of debris, highlighting the very real dangers of our increasingly cluttered orbit. More recently, the International Space Station, ISS, has had to maneuver several times to avoid potential collisions with debris. In 2021 alone, the ISS conducted 3 debris avoidance maneuvers. These near misses are a stark reminder of the constant threat posed by space debris and the need for urgent action. The dangers posed by space debris extend far beyond the immediate threat to spacecraft. Every piece of debris, no matter how small, travels at incredibly high speeds, turning even a tiny fragment into a potential bullet that can cause catastrophic damage. Satellites are vital to our modern world. They are the silent workhorses orbiting above, enabling a myriad of services that we often take for granted. They provide communication, navigation, weather forecasting, and Earth observation data that we rely on every day. From making a simple phone call to navigating through a city, satellites play an indispensable role in our daily lives. Damage to or loss of these satellites would have severe consequences for our global infrastructure. The ripple effects would be felt across various sectors, including transportation, finance, and emergency services. Imagine a world without GPS, accurate weather forecasts, or even internet access. The disruption to our daily lives would be immense, affecting everything from personal convenience to national security. That's the potential cost of inaction on space debris. The growing cloud of debris poses a significant threat to the sustainability of space activities. Furthermore, the increasing debris field threatens the future of space exploration. As we continue to send more missions into space, the risk of collision grows, making it more challenging to safely navigate through the cluttered environment. Launching missions into an increasingly hazardous environment is not only risky but also costly, potentially hindering our progress in exploring the cosmos. The stakes are indeed high, and addressing the issue of space debris is crucial for the future of space exploration and the preservation of our modern way of life. Thankfully, the international community recognizes the severity of the space debris problem and is actively pursuing solutions. These efforts involve two main approaches: debris mitigation and debris removal. Debris mitigation focuses on preventing the creation of new debris. This includes designing satellites and rockets to minimize the release of debris during launch and operations, as well as deorbiting satellites at the end of their life cycle. Deorbiting involves lowering a satellite's altitude so it re-enters the Earth's atmosphere and burns up harmlessly. Section 6. A sustainable future in orbit, a shared responsibility. Debris removal, on the other hand, aims to actively capture and remove existing debris from orbit. Several innovative technologies are being developed for this purpose, including nets, harpoons, and even lasers. These technologies could potentially capture debris and either deorbit it or move it to a less congested area of space. Addressing the space debris problem requires a global effort. International cooperation is crucial to establish common guidelines and regulations for responsible space activities. By working together, we can ensure a sustainable future for space exploration for generations to come. Section 7. International cooperation, the key to success. International cooperation is not a futuristic ideal, it's already happening. The Interagency Space Debris Coordination Committee, comprising space agencies from around the world, has been working for decades to develop mitigation guidelines and share information on space debris. These guidelines encourage responsible behavior in space, such as passivation, designing for end-of-life disposal, and avoiding intentional satellite destruction. While these guidelines are a good starting point, more stringent international treaties and agreements are necessary to ensure compliance and long-term sustainability in orbit. Section 8. Technological innovations, from nets to lasers. While international cooperation lays the groundwork, technological innovations provide the tools to tackle the debris already in orbit. Several promising technologies are being developed and tested, each with its own advantages and challenges. Nets, for example, could capture large pieces of debris, while harpoons could grapple onto specific targets. Ground-based lasers could be used to nudge debris into the atmosphere, causing it to burn up. Each of these technologies presents unique technical challenges and requires further development before it can be deployed on a large scale. Section 9. Our future beyond Earth, keeping space safe for exploration. Space debris is a challenge, but it's a solvable one. By fostering international cooperation, implementing responsible space practices, and setting up stringent regulations, we can mitigate the risks posed by space debris. This involves not only tracking and monitoring existing debris, but also ensuring that new missions adhere to guidelines that minimize the creation of additional debris. Investing in innovative technologies is crucial. Engineers and scientists are developing advanced methods to capture and remove debris from orbit. These include robotic arms, nets, and even laser systems designed to nudge debris out of harm's way. Such technologies are still in their nascent stages, but they hold great promise for the future. We can clean up our act in orbit. Imagine a future where space missions are not only about exploration, but also about maintaining the health of our orbital environment. This vision is becoming a reality as more countries and private companies invest in space cleanup missions. The future of space exploration hinges on our ability to address this pressing issue. If we fail to act, the increasing amount of debris could make certain orbits unusable, hindering scientific research and commercial activities. However, with concerted efforts, we can turn this challenge into an opportunity for innovation and collaboration. Remember, space is not just an empty void, it's a shared resource. Every satellite, every piece of equipment we send up there, has a lasting impact on this delicate environment. It's our responsibility to ensure that space remains a viable domain for future generations. Just as we strive to protect our environment here on Earth, we must also be responsible stewards of space. The principles of sustainability and conservation that we apply on our planet should extend to our activities in space. we must also be responsible stewards of space. This means designing satellites that can be deorbited safely at the end of their life cycles and developing international treaties that enforce these practices. By working together, we can ensure that future generations inherit a pristine cosmos, ripe for exploration and discovery. The stars have always inspired us to dream big, and by keeping space safe, we can continue to reach for them.